Yes, in the last lecture, we covered the CPLD. Now, in this lecture, we are going to start the FPGA. Now, this FPGA is a little bit same as that of the CPLD, but here the we can produce or design the more complex logic very simple way with the help of the FPGA. And whatever the interconnections are there in CPLD, these are totally based around PAL and GL technology as a logic blocks are there. Okay, and all these CPLD devices and SPD devices are totally based around SPO, that is the sum of the product logic, sum of the product logic. But these FPGAs are the different, that is these are not based on the sum of the product, that is a SPO. Okay, so its architecture is different, and that architecture right now we are going to see here. Okay, but at the same time, very high logic capacity is here for the FPGA. So what is this? Right now we are going to see it is in detail right now. Here it is the block diagram. Okay, so as this FPGA is nothing but the field programmable gate array. We already discussed in last lecture that these FPGA devices are of two types, that is the coarse grain and fine grain. So there we are not going in detail for this as a coarse grain and the fine grain. Right now we are going to see as a this is as a general block diagram of the FPGA devices here. Now these FPGA devices basically consist of logic blocks. It contains of your the logic blocks. There in a CPLD it is we have to call it the lab, that is a logic array block, and here we call it as a array of logic block. But here it is we to put it is as a logic block is there. Okay, and these logic blocks, there is array of the logic block with the programmable a row and column interconnections are available there as the interconnection array interface is to be available in CPLD, same as that of here. But this is the one interface is there, and around that you are the all the logic blocks are there. There is a labs are there. But here is what happened. It is an array of logic block, and there are the in between you are the logic block of this array. There are the rows and column interconnects are there. So all these interconnects are the programmable. As we see, it is in a the programmable interpret array is there in CPLD. Now here, this FPGA, there is as we see that there is the FPGA is totally the different than that of your the CPLD, because the CPLD is based on sum of product, but here this FPGA is based on lookup table. It is based on lookup table, and this lookup table is a type of array. It is a type of memory. Okay. So here we have to say that the architecture of FPGA is based on type of array called lookup table, and in CPLD it is based on sum of the product logic there. Okay, and here for this FPGA, this also utilizes the use of multiplex device. That is, we have to say that you are the multiplexer to generate the logic function, to generate the various logic function as we discussed it is in the previous chapters are there, or we have to say that we see it is from the BSc 1 there. That is, with the help of the multiplexer we can generate the various logic expressions are there, or the logic functions are same as that of here this as a multiplex device is utilized for your the generation of logic functions are there. Now, this is the complete view of this uh, FPGA device is here. There is these are the programmable IOs. Okay, there is IO blocks are there. Here is the array of logic blocks. These are surrounded by the interconnecting interface. We call it as a row and the column. Programmable interconnect is there. Okay. And right now we are going to discuss one by one what is this as a FPGA is there. There is this as a FPGA device. Now in this as a logic blocks, in this logic, that is first we go for the logic block, then we go for the interconnect technology. Okay. So here as this as a logic block, as we have to consider that this logic block has several logic elements. It has a several logic element. I have to show that here the n number of the logic elements. As I have to show that here the n number of the logic elements, that this depends upon the manufacturing technology and what is the variant of this FPGA device is there. Okay. And generally here we have to say that as the single FPGA device we have to consider, there are the various logic blocks are there. Every logic blocks has the n number of the logic element. These are the not here the in there definitely the definite number of the figure is there. But in generally we have to say that the FPGA device has several thousands logic elements in a single chip. It depends upon the which is the variant. Now here for every logic block, here is the column interconnect is also available and the row interconnect is also available. And when there is the cross of this row and this column is there, at that time there is also the interface is also available for the row and the column interface is there. Okay. Now, what is this as a logic element? Now, if you have to see that you have the logic element, that is as we see it is in a previous, that is your the macro cell is there for as a logic element. Same at the top, this is also the typical logic element. We cannot say as here as it is a macro cell, but it is a logic element of the FPGA device there. Okay. Now, as this logic cell, I have to show that here, and it has the 4 inputs. It has the 4 inputs, and we can see also here it is a 4 input in a lookup table, and it is a programmable. So this lookup table will generate as an output. This is your the logic function. It generates your the logic function here. And there we have to see in a CPLD that AND array is programmable and the OR array is fixed. So we are generating here, there it is a sum of the product logic functions as per our design. But here is not the such situation that here we are generating using the lookup table the logic function or expression. So here we have to say that the lookup table is nothing but your the logic function generator is there. Now this lookup table, it generates the logic functions as well as is also generate. It generates the sum of the product function also there, because the sum of the product function is also the one of the logic function. Okay, same as that of there is lookup table does not generate SOP. It is not the issue. But CPLD only generate the logic function. It is in the terms of SOP. It is in terms of the SOP. Whereas this lookup table of FPGA, it generate the logic function or expression in the terms of SOP. in the terms of the SOP, as well as it generate the different logic functions. We can take as a, for example, as a adder, subtractor, comparator. So these logic functions are also generated by this lookup table. So how these are there, that also we can see afterwards. That also we can see the incoming next paragraph there. Okay. So here this is the comparator. Now here, as these are the lookup tables are there, these are to be cascaded. These are cascaded with other logic elements are also. That is, this lookup table has also the facility of cascading your the another logic elements are there. That is, this is with the help of the cascading technology there. Now here we can have here same as that of the CPLD, that is a programmable select there. Now here the cascade logic is available, that is along with this output of the lookup table, if the another logic element has the ready function, that this can be cascaded here, or after the cascading, if this function is needed for your the next logic element, that this is to be delivered to the next logic element is also there. That facility is also available. At the same time, output of this cascade logic has further the programmable select as it is in a CPLD. That is, either we have to give this output of your the lookup table after the cascade logic as it is to the output, or with your the registered function, with the register function. So for this as a register function, here is the flip-flop is utilized. Here the flip-flop is utilized. So with the help of that, either we are getting as an output for your the IO port, or your the next logic element whenever it is to be needed. Either it is the registered output, or as it is from the lookup table through your the cascade logic is there. At the same time, to carry out the function of this logic element properly, there are also we are needed the clock clear preset select logic. So this logic we can select with the help of the. So here, as I told, that is, we can have your the preset and all these logic functions are there. That is, if we have to say that your the clock and the reset logic is there. This clock clear preset we have there. So this is also needed for your the lookup table, as well as it is needed for your the flip flop. It is to be given, or we have to provide here as a global clocks are also available, clear, and the presets are available there. So this is about your the this as a FPGA logic element. So this logic element, as we have to compare with the CPLD, it is simple one. It is simple one. It is not the complex, but that is. But at the same time, it depends upon the which type of the variant of your the FPGA and which type of the technology we are going to utilize there. Okay. Now, so what is the lookup table? That also we are going to see here right now. Now here, this is your the lookup table as an example. Now here in this lookup table, we have to show that it is 8 by 1 memory. It is 8 by 1. That is, this has the as a simple diagram, and with the help of this, we want to generate the SOP function. Suppose we have to say that where the 3 inputs are there, and from that we want to see the SOP function is there. Okay. So how we are to getting that SOP function and what is to be needed there? That is, has here 8 outputs are there. Now from this as a 8 output, our function is here for this as a lookup table, that A bar B C bar plus A B bar C plus A B C is that. That type of the SOP function we wants here. and it has the 3 input. So here what we have to say that number of the logic, because as the 3 inputs are there, these 3 inputs provide you are the 8 different cases are there from your the A bar, B bar, C bar to your the A, B, C. That is that we have to say that you are the I mean in a K map, or in a second year we have to, in a first year we see that is the fundamental product is there. Same as that of here, which outputs are high there, which the fundamental products are high, that we have to add it there with the help of your the OR gate. Okay, so this third line we have to make it is 1 there by selecting your the proper logic there, and that it shows it is A bar, B, C bar. Then your the sixth line we have to put it is high. It is A, B bar, C, and the eighth line we have to put it is high. It is A, B, C is there. So that 3 terms we have to require, that is A bar, B, C bar, A, B bar, C, and A, B, C. That is what are these as a zigzag lines are here, draw here in this box there. That is that output lines we have to make it is 1 there. Same that the fundamental product there. And here we are to getting as a out as A bar, B, C bar plus A, B bar, C plus A, B, C there. So this is the logic of your the simple logic here. I have to say that it is 8 by 1 lookup table there. Here the another lookup table, we have to say that here it is for the full adder function, and it has the 8 by 2 lookup table. 8 by 2 lookup table. That is, it has the 8 outputs already available from the lookup table here. And what are the final outputs we are getting? It is 2 there. That is, one is the summation and other is your the carry out is there. Now here, as for the summation as a full adder, and what is the logic expression is there, that what we learned it is in a first year. It is the C is equals to here it is the summation is equals to A bar, B bar, C in plus A bar, B, C in bar plus A, B bar, C in bar plus A, B, C in. Okay, this is the logic expression we are needed for your the summation of these 3 inputs are there, and these are to be taken here as a for the first column, and here we are to getting this as a summation term. What we learn it is in a BSc 1 there for your the full adder. Now here C out is equals to that also the logic function we see it is in a first year, that it is A bar, B, C in plus A, B bar, C in plus A, B, C in bar plus A, B, C in is there. So with the help of that, we can get your the out as a C out is to be there. We are getting your the C out. So these are the terminologies are there. Okay. So with the help of this, we can get the out there. So this is the lookup table for your the 8 by 2, and the previous one is to be 8 by 1. There is only one output level is there, and here are the 2 output functions we can avail. This is the basic fundamental things of your the lookup table are there. So in this way, and these are the programmable. These are program. So once it is programmed, this as a lookup table as an adder. So whenever the adder is required there, that this lookup table we are calling there. Okay, to perform the function of your the full adder. To perform the function of full adder there. Okay, so this is about your the lookup table. Then we go for your the second is the interconnection technology. That is in your the SPLD and CPLD. We see that your the CMOS, there is a CMOS technology is there. Okay, that is if you have to take it is the fuse technology, then it is one-time programmable, and if you take your the CMOS technology is there, that is it is the many-time programmable there. Okay, so the chip is to be available for reprogrammable there. And for this as a reprogrammable, we are availing here the E square CMOS technology. So here the with the help of this, also here for the FPGA E square CMOS technology is to be utilized. Okay, same as the topic is in a CPLD. So with the help of that, we can get your the programmable interconnect. With the help of this is here. See, for that purpose, in the CMOS technology, we are utilizing the SRAM interconnection. That is the static RAM interconnection cells that we are going to utilize. Now, this is here in the first diagram. It is shown the basic concept of antifuse interconnection, and here it is to be static RAM is there. That is when we are for this as a static RAM, we are giving for this gate as a 0 input, then it is the off there. And when we are to provide it is 1 there, then this row and the column is interconnect. That is this CMOS device is on there. Okay, so the link is to be established. So here it is for the due to the antifuse technology, it is open there. That is, it is unprogrammed. And when it is programmed, the link is to be established in between the row and the column is there. Okay, so but here we have to say that it is the CMOS technology is utilized because we want this FPGA devices for your the reprogrammable capacity, not your the one-time programmable. Okay, so for your the reprogrammable technology, it is a CMOS technology. Is where CMOS technology is utilized, and in that the basic concept is SRAM interconnection. Okay, so this is about your the interconnection. Now also here we can see the one specific FPGA is there. As a, for example, what is to be given that it is the from the Ultra, that is Flex family is there, that Flex 10K family is there. Okay, so in this as a Flex 10K family, there are the number of logic array blocks are there, and in every logic array block, that is, if you have to say that how many number of the logic blocks are there depends upon the variant in this Ultra FPGA. It is from 72 to 1520, 72 to 1520. Okay, it depends upon which variant is there. Now here, each lab contains, now what are these are the number of the labs are there, and each lab here contain the logic elements are there. Okay, so if logic elements are there, so how many number of these logic elements are in a one lab, or the logic blocks are there, these are to be 8. So if you take here the multiplication of this, that is what is the highest number we have to getting of the logic elements in a one FPGA of this Ultra family. It is a 12,116 logic elements are there. Okay. At the same time, this also has some random access memory is there. This is the block of your the random access memory for your the temporary utilization of the functions are there, and this area is also here is a fix is there, that it is called as the embedded array block. That is, this embedded array block is nothing but your the memory area. That is, this is to be utilized for your the general purpose. We have to say that it is embedded array block is there. Okay, now as these are the labs, what we have to say that, and the input output elements are there, logic array blocks are there, and at the same time your the logic elements are there, and all these logic elements are same as that of as we already discussed as a lookup table. And look, it's the diagram, that is what is this as a Ultra Flex 10K family block diagram is there. That is, these are the input output elements which are connected on all the sides. These are the row interconnects, these are the column interconnects. Okay, now for this row and column element interconnect, there is the array of your the logic blocks are there. There is the separate area is the embedded array block is there. That is your the random access memory for the general purpose is here. And here the from every logic element there is the interconnection to your the row as well as for the column. And what is your this cross section of your this row and the column? There is also the programmable interconnect. That is FPGA as compared to CPLD has three types of your the programmable interconnect. That is row to row, row to column interconnect, then logic element to row interconnect, and the logic element to column interconnect. So all these interconnect facilities are available here. Okay, so this we have to say that for your the IO elements. This we have to say that for the IO element, and this for your the FlexK K family. Now, if you have to go for it's the inside that, that is, if you have to see that this is a logic element, that is, as I told that there are the 8 number of your the logic elements are in one lab there. Okay, here we have to see that, and the number of labs as I discussed here, the 75 to 1500 are there, and these are we have to say that here the one logic array. And what is your the every this logic element is there? What is it the block diagram? That block diagram is here. That it is the lookup table. Then your the cascade chain is there. The cascade in, cascade out. It is given to your the flip flop and associated logic, and this is the programmable select. Either we have to want your the register output, or we have to require we need your the lookup table output is there. Okay, and this is to the main interconnection, and it is to the local interconnection. Okay, this also here we have to take your the these are the band of the input. You have to show that for the flip flop that it has your the all these three inputs, that is your the clear, preset, and the clock is there. That is from the that logic block, that is clock array and preset logic block is there. Now here the carry chain is also available. That is, these are depends upon your the which type of the manufacturer is there, and his which variant is there, depends upon all these things are. That is, here is the carry in, that is from the previous one. And at the same time, if here is the carry is to be generated in this lookup table, that is, this is to be provided to the next logic element is there. So all these facilities are available here. So this is about your the FPGA. So for the today's lecture, we will stop here. That we cover in this lecture right now the FPGA. Okay, thank you.